This is a fully CNC'd aluminium bike frame, and just a few hours ago, it started life as a solid block of aluminium. This is a rare and exclusive look inside a bicycle factory. We'll see a process of building bike from the raw materials, how colour is added, and how they end up turning from a solid block of metal into a bike ready to rip. Pole bicycles are based in Finland, and Leo Kokkonen is the mastermind behind it all. I asked him to go right back to the start of how a bike is born. Where does the idea come from, and what is the creative process?
So this is what I go through my head. I talk with people and I ask around, like, how do they want to mount a bike? What's cool about it? What do you want to achieve? And after you get that idea in your head that this is how I want to ride, then when you lock that in, then you can create a bike. And then you make a fast mock-up. The fastest mock-up you can make of that idea is the way to go. And then you test it.
He also rides fast, very fast, and often tests his bikes to race-winning pace.
I do the industrial design, and then I do the mechanical design, and then I also do the simulation. So there's everything in here when I drill in deeper, so I can see the wheels moving. How do we install the motor, for example? Are we using this kind of opening for the battery? What kind of other features you have? Internal cable routing, what's your philosophy on that?
I was at the Pole HQ for 3 days, and I quickly learned that Leo's mind works at 1,000 miles per hour, and he barely stops. After the idea is conceived, designed and coded, the production process can be started immediately. The factory floor is located just down the hallway, so to turn it around from an idea to a bike that's rideable is incredibly quick.
That turns into this.
The factory is full of parts that look like they're from the Terminator. Leo explains a little bit more about this production process.
So what have we got going on here? I can see lots of blocks of aluminium.
This is swing arms. So these are passivated and ready to bond. We have the insides machined. Here you can, for example, see that line. So there's the wall thickness is getting thinner towards the end.
So these have already been pre-machined for these. Effectively, that's the inside.
Yeah, this
right?
is the inside.
That's the negative.
Yeah.
You're bonding it together.
Yeah.
So once it's bonded, then it's going to go to the next stage, which is essentially you're going to cut away and cut away the outside to reveal the actual the finished piece.
Let me just explain what is hard about it. So we have now two pieces what have their independent insides, and now we're going to do the outside. So the wall thickness, if you want to reach that plus minus 0.1 millimeter tolerances, we need to know where it is inside this block to begin with. It cannot be like turned or up or down. We need to know exactly where it is. Any CNC machinists, they know that whenever you detach the part from the machine and then you start machining it again, it's going to be hard to find out where it is. Well, you want to make it quick as well. So you can make one easy, you put all your effort to make one, and then you try to make second one, which you want to be able to make something that works, holds up all the stress and goes through the fatigue testing, and you want to win races with it. Next issue is to make more of it. For example, many electric vehicles on the market, they go with a prototype and they say these cool things that we have this and this features. They can make a couple of them because all the smart people are working on one or two prototypes. And then you need to make masses. You need to solve a huge amount of problems after that first prototype.
This door looks pretty secret. It says no cameras over there.
Yeah.
Can we go in and have a look?
Yeah, we can go in now. So it's going to be noisy here.
Yeah.
So this is the CNC shop.
Go ahead.
So we're producing 24/5. So we're at the maximum of our capacity.
So this is a bonded swing arm, right?
Yeah, this is a bonded swing arm. This one has already the insides machined, and it's a block. These are finished. So this is from the last phase of it. Front triangle is going in there.
Okay.
The swing arms are here. So now you can see the first stage is coming out from here. We used to make 2 at one go. Now we're making 3 at one go. So that is something that we're trying to improve all the time. So more done with one hold, so to speak.
Got it. And this bigger machine over here, this is a frame in here.
That is working the front triangle.
That is so cool.
Yeah.
That is absolutely amazing seeing this frame being cut out of that block of aluminium.
Yeah.
And how long will this take to produce this finished front triangle?
1 hour-ish.
Yeah. And you're running 24/5, you said. So you have a day shift, a night shift. So this is always going. 5 days a week.
Running, okay. The only stop is when we take the pieces out and load the next one in. So we have this zero clamping system where we can just prepare the next piece, and we just use a crane to put it in. This zero clamping system is 1,000 of millimeter accurate every time. So we try to minimize the stop of the spindle.
So when you get the frame out, there's very rarely faults with it.
It's very rarely.
Pretty good.
There might be a tool breakage or something that we need to start from from the middle again, but we can work these out. I don't know, like 99% of the time.
Yeah.
But maybe 1 in 100 or even less is faulty.
So we're talking 99.9%. With 0.001% accuracy in terms of tolerance.
Yeah, when you connect it, but what we accept in the outside surfaces is 0.1 millimeter plus or minus tolerance, but that is small. And just remember, that's precision. Like it's high precision machining, then that's something that is not normal in this industry. That something is like only the headsets and like forks have this kind of tolerances, like the shocks and all that kind of stuff, but not the frames.
Yeah.
They're like way off the tolerances that we do normally.
That's so cool seeing it like this in this half-finished form here, right?
Yeah.
And then this will go back in to have the other half machined out.
Yeah.
Yeah.
So
it gets.
There you can see.
Oh, okay.
That's the.
So it basically goes in,
finalized.
flipped around, and then it's starting on that side. Okay.
Yeah. Whenever you take it off and make another hold, you lose kind of the coordinates. You need to find the coordinates again. That is not easy. You know, it's like when you detach something and you put it back in the other way around. You need to find the 0 points. Yeah. And then you need to start machining again. So when you look at this part, you see how this side and this side match.
Yes.
That is the thing that is hard.
Yeah, because there's two processes to that, right? So you're putting it in, then turning it over.
Yeah. So if you reclamp it a little bit to the side, and the machine doesn't know where it is, it's here you can see that there's no. There's no step.
The aluminium used is 7075 T6. It's chosen for its strength and resilience, and the final CNC'd frames and finish looks absolutely stunning.
We've gone through a lot of the process and how the bike is CNC machined, and then what is going on here? I can see loads of what looks like tubs of water, what looks like it might be a little bit of a paint shop, but done the Pole way. So explain what this is.
So this is an electrophoretic clear coat line.
So not anodizing, electrophoretic coating. So what is that? What does that mean?
So there's dipping pools where you first treat the metal. So first we wash all the grease and everything was cutting food or whatever. Then there's this called desmat. So this is what takes off the hard material, like oxidation, because anything that touches air, metals, they start oxidating immediately. This makes sure actually that when you have the raw clear, it doesn't look like aluminum. It looks more like silver because there's no oxidation on top of the aluminum. So it's really the cut surface of the of the aluminum. Then we close the surface chemically so it doesn't oxidate anymore. So it's called passivation. We do it chemically. And then we rinse it. And this one already went through the clear coat. So this is the electrophoretic clear coat. So we have electric current that goes through the pool. And when you have something which is metal, it just then it sticks to the frame. Is this getting a color?
Yeah.
Yes, true gold.
Oh wow!
Yeah.
So we're going to see it go from this.
Yeah. So now it goes to the, and this is the next that goes to the pool where we have the pigment, and it goes into the clear coat with osmosis. It is like fascinating for me as well because it's kind of like just dip in pools and all that. You get that end result is really.
And what I can tell being in here is I can't smell anything that smells like chemical or
you could drink in any one of these and you wouldn't drink. Like maybe you would feel a little bit bad, but you wouldn't have any. You wouldn't need to go to doctor.
Okay.
To kind of like.
So it's not highly toxic.
No.
Or any. Okay.
There's a little bit of chrome in the passivation, but it's very low amount of it. So. And all of this water is being recycled. So all the chemicals will be, they're being gathered. They'll be sent to a facility that gathers all the chemicals and it's being recycled. Everything goes back to the processes. We want it to go as clean as possible and also the work safety of our employees because I don't want anyone to there's some chemicals are like so strong that if you drop something on your hand, it just goes through your bones and everything.
Sorry, that is so cool.
Yeah. It doesn't look very like transparent and everything now. And this is something that what I think is weird is that now we rinse it. This is clean water, but there's some pigment in it. So we change these waters like every now and again. This is more or less like a half an hour process before it goes to the oven. But in the oven, we just heat it up so all the moisture gets off. So, and it hardens this is plastic basically. It's a really thin layer of plastic.
Okay.
6 to 10 microns. We're trying to minimize so nothing kind of drops in the oven on top of the top tube. So on the top tube, you don't want anything like a spot there. So we make sure that there's no invisible places.
Got it.
Some kind of defect. The cost of that color is really that we make sure that it's good because we sometimes have to scrap after this. There's no way of getting the color off. There's way, but it's something that we don't want to do.
Yeah. So if this doesn't, the end result is not acceptable, the whole frame is scrapped and then
or we use it demo it if there's nothing really wrong with it, so we use it as a demo. There's not many of these, but before we got this process, we had to scrap quite a lot of stuff.
When we say scrap, we're talking recycle.
We will recycle it. There's massive load of effort that is going to waste because we've done CNC machining and bonding and everything. So this has to be a very precise process. So we put a lot of effort to make it perfect.
After the clear coat is finalised, the frames then have their bearings pressed in. They go through a QC process, and customers can have protective film added to keep it in top condition.
You mentioned that part of the buying process, people can customise the bikes, and I know that you make all of this frame material to protect the bike as well. This is set up to be, you've got a piece on the front.
So somebody's working on this, so we install the protective film. So this is designed just for our frames, and this material has been tested, and we've done so many iterations to find the right material, which is good for the CNC surfaces. And so we apply these in-house.
I've got to ask about this over here. Because it looks like we've got what I can only describe as end of hose pipes on there. Is it just that they magnificently and coincidentally fit your links?
Yes, exactly. There's one employee who I gave him the task to make a jig where we can put these on, and it's funny that, I mean, what is the coincidence that this part fits?
That is a hose lock, isn't it?
Yeah.
That is what you'd have on your hose pipe.
Yeah. And that fits exactly this bearing seat, and we can lock it in like that, and then we can start work with this. And also this part is that, like, you have these are the axles that are the monocoque axles. They go in just like that.
So you didn't design your axles to fit hose lock?
No, that was just pure luck. I like to do all the processes myself, so that then I just don't design something that is hard to work with. So, for example, here, this is the sticker that goes into this link. So first I put the rib, like the center of it. We don't have any specialists, so we try to make everything so that almost anyone can work with.
So a lot of companies have to wait maybe 2 years, 3 years before they make any changes to their frames, because of molds and that kind of thing. But I think listening to what you've been explaining, you can design something and put it into production quite quickly. So I've noticed there's numbers on here, and you can be quite adaptive as to the changes that you make really quickly and put them into production really quickly. Yeah. So for example, if you've noticed something that you think could be better on a frame, you don't need to wait 2 years to introduce it, right? You can do it quite quickly.
Well, we don't want to do massive changes, we just because we think it's better. I've known that we're going to change that part for a while, but like, it doesn't make sense to make a change to the looks of the bike in the middle of production. So, and that is a non-functional change.
So it's just an aesthetic piece.
Yeah, that's mainly aesthetics. We changed a little bit of that internally as well, which is easier to make, but that is not added value to the customer. So, so we wanted to have like a overhaul it. But during the production, we have changed so many things. Most of the changes are not because there's an error or something. We just want to make it more efficient. So if it doesn't affect the customer, like the value they're buying, we're going to change it anyway.
When did you start? What year?
2013. So September, we're 10 years old.
Okay, congratulations. And I guess there's been some learns in that process. I mean, it's not easy to start a bike company, and
no, I wouldn't recommend.
Wouldn't recommend it.
Well, I mean, it's established industry.
Yeah.
So going into the industry, you need a new angle, and the thing is that you can get kind of a couple of years worth monetizing it, and then you need to come up with a new stuff, because the other competitors in the industry kind of follows that, and you want some growth as well. So to be able to handle the customer service and marketing, and you need to keep up with the pace with the new innovations, like for example, the new SRAM derailleur. If you're not ready for that, like if you didn't follow with all the standards earlier, now you need to redesign your swing arm and probably something else, because there's clearances and all that kind of stuff involved. If you are in a market where there's competition, you need to be able to have an angle that people really invest in. So I don't know, it's like we're global. We sell it to 40 different countries. So I think that's one of our strengths, so we can reach people globally. But I mean, how do you do that? It's not easy.
No, I can imagine it's not easy. It's a pretty competitive industry. But
it is.
It seems to me, from seeing everything, you're carving out your own segment of this industry, and it's a pretty fierce piece of competition. But you've got a product that is very different in terms of the looks, but the performance of it is outstanding. Where do you go from here? Like, what's kind of next for Pole?
I mean, like now we have a niche that works really good, and we have come up with this new manufacturing technology, which is surprisingly efficient. As you could go well, what is mass production? I wouldn't say mass, but serious production for, I don't know, 10,000 units or something like that. That's achievable, and we can be
10,000 units per
year annually.
Talking,
yeah. And that could be well, I don't know, like 5,000 square meters.
You'll be able to fit it in this factory that you've got now?
Not this one. We need a new one for that. But I mean, it is possible, and because it's automation, you don't need that many people, and we can do it in Finland. Which is cool and possible. Of course, there's a big risk involved. When you invest into this kind of machines, you need to be able to sell and convince people to buy into it. And I think we have reached that point. We're selling pretty decent numbers already, and the quality is good, and we know that we can continue with this.
These CNC machines don't look cheap to me, so I'm sure there's a big investment in some of these machines. And if you're thinking about a bigger premises, I'm guessing that means more machines. And what's the cost of one of these machines, if you don't mind me asking?
Well, it really depends what kind of machine you get and what type of automation you're integrating. But what we use at the moment is like 3-axis milling, and which is, let's say, from 100,000 to 300,000 is what we have at the moment. But we have one machine which costs 400,000 as well. And if we would go with new factory, we're putting 1 million in one unit, because it's going to do more of that stuff. So
1 million for one machine, basically.
One machine, yeah.
But that can be more automated. It can be quicker as well, I guess.
Yeah, quicker, more automated. You can do like everything comes into seconds of some tool change or something like that. When you start making masses, like when you do 24/7 something, you need reliability. So if it's quicker service times or whatever. So investing into that kind of stuff is, you invest into the future of flexibility as well. So comparing to other manufacturing methods where you need to invest into molds, which is, if you want to change something, you need to invest again into the molds. And if you make a new model, you need to invest again into and then you scrap the molds after you have the next model. So with the CNC machines, you can make variety of products.
Well, that's how you've been able to adapt to the Voima ID so quickly with minimal cost. I should have thought, other than you having to design a new place for the cutout and some more refinements, because you've been able to do that very quickly. Whereas I guess a traditional manufacturer may need to have a bit more of a lead time in order to make that happen. Maybe new molds even, right?
And we're make to order. So we started with the traditional method, welding the frames in Taiwan, and we need to buy a batch. And then when you get the batch, you get a certain color, size, model. And before they end, like before you have them, you haven't sold any of that. And that batch floats on the ocean for, I don't know, 2 months. And then you need to handle with the customs, and you're investing quite a lot into that working capital. You invest into the batch, and you don't necessarily know isn't it defects. After they leave the factory, you need to be there to inspect that, and that takes quite a lot of time to measure everything. You don't know.
Your office is like 30 meters away from the production line.
Yeah.
You can basically send something to production and analyze it immediately. Right. Okay.
Yeah. So it's all about just we're coding some sort of, like, it's kind of coding that we code the new frame instead of I don't know. It's like it's not printing. It's removing material, and I believe in this removing material method is so much more. It's conventional already, but we're using it a different way. We bond the frames, and we have this new way how to make it. And what I think surprised most of the people when I tell how quick it is, how reliable it is, and all that kind of stuff. So we use a material that is not it's not conventional in the industry. It's twice stronger than conventional aluminum, and it's still metal. You can recycle it. There's the environmental point as well, because when you produce here, you get, like, the carbon emissions are very, very low, and the nature is clean, and like all that kind of ethical part of it, which is not necessarily the thing that people invest into, but it's a value that is nice to have. So if you break your frame, for example, or it comes to end of life, you don't need to think that, oh, I'm going to put this piece of hazardous material into trash.
When you're CNCing, there is waste product, but you can reuse all of that, or it can go back into the chain effectively and be reused. So there's minimal, if any, waste from producing one of these bicycles.
Yeah, there's only minimum waste that it kind of burns into when you melt something. But it's like it's infinitely recyclable material. It goes to something else like car wheels or, I don't know, Coke canisters or whatever. So there's a difference between, for example, carbon composites, because the aluminum is, of course, it's mining and it's dirty when you do it, but when it enters the system, it's clean after that. It's really versatile material. You can do different shapes. You can form the aluminum you can extrude it, you can make it as a billet, CNC machine it and forge it, or like different ways of using the same materials.
Seeing behind the curtain of how a bike is manufactured was really fascinating. What really stood out to me was how Leo and his company are really open to showing and sharing everything, which in this industry, which often hides a lot of the manufacturing and design process, is quite rare to see. Leo and his team have created some outstanding bicycles, and I wish the company the best of success in the future.